Now we calculate speed of transverse waves in stretch string. Here we consider a spring which one end is fixed and other end passes through frictionless pulley and attached with mass m. Now this is the direction of tension. As we know, the tension is away from fixed point or the point where it attach. Here we consider a wave. Now we consider a small pulse. So we take small pulse here. This is our small pulse. Here we take a small part of our pulse. We take a small, this is small part of our pulse. This pulse is in circular motion. We take that portion that is in circular curve path. So here we take a radius from center O from the small part. So we take this small part of our pulse, that part is equals to delta S. Here this is equals to radius and the angle between them is theta on both sides from center. Here we draw our tension force, that is tangential tension. So we resolve our tension in two components. One is x-axis and other is sine axis. So we divide tension 1 in x-axis, that is t cos theta, and tension 2 t2 cos theta. Both tensions are in opposite direction, and the vertical component of both tensions are in same direction. So here we have only vertical component. Horizontal component cancel each other. So we write it as 2t sine theta, because we have two parts of y component and we add this. Here if we look at the figure, theta is very small, so we consider that our theta is almost equal to sine theta. By taking this approximation, we write 2t sine theta is almost equals to 2t theta. This is our equation 1. Now we consider this part look like this. Here angle is 2 theta because from center on both sides the angle is theta, so we add these two angles, theta plus theta, we get 2 theta. According to arc length formula, we have delta S is equals to 2 theta r. This is our equation 2. Now we know that we suppose that there is some linear mass density, because it has some mass, the body which has some mass, then it has some density. Here the mass is in linear, mass has linear mass density, that is equals to mass, linear mass density is equals to mass upon length. Here we take a small part of this string, that is delta S, so this is equals to delta S, so our mass becomes m is equals to mu delta S. This is our equation 3. Now we put the value of delta S, that is 2 theta r, so we get m is equals to mu 2 theta r. Now, as we discuss that this part is in curve or circular path having some radius, so due to this circular path we apply here centripetal force, because the centripetal force is the force which maintain body around or around a center. So we write 2 t theta is equals to centripetal force, that is equals to mv square r. Here we put value of m, that is mu 2 theta r, v square r. Here we cancel r, 2 theta is also cancelled, so we have v square is equals to t upon mu, because mu is in multiplication. When it comes on other side, then it comes in division. So by taking roots we get v is equals to under root t mu.